Hello, my CNC brother or sister. I'm Garrett with IDC Woodcraft, the company that provides you with the CNC router bits to carve out your amazing CNC projects. Welcome to this video where I am going to walk you through the process of setting up a project on my Altmill CNC router. This video is intended to teach you the thinking, the methodologies when you are setting up a project and running it out. So the project we're going to be doing is this Marble Maze here. And this is a two-part type of project. It's got the cover that we have to make and the body, the maze itself. So this is going to be an educational video for you. This is part 3 of a 3-part video series. However, this video is a standalone video, meaning you can watch this and not watch the other 2 videos that go along with this. But here's what those videos are. Video number 1 actually walks you through the design process of making a marble maze, how to get the maze itself and import it into your design, and all the thinking that you need to take into account as you're designing a project, especially when you have an assembly that you're making. We're making the cover and the body itself. So I'm taking you through the entire design process. You will learn a ton about designing by watching that video. Video 2 walks you through the methodology of setting up your toolpaths, thinking about the order of operations that you want to actually set your toolpaths up on. And of course, this video, video 3, where I walk you through making this project on your CNC router. Video 1 and 2 are linked down below in the description of this video, as well as all the other things that I talk about in the video, including the bits that I use and what have you. With that, it is time to get on with this video where we start going through the entire process. The first thing I'm going to do is talk about the strategy that we need to do in order to make the marble maze, especially since you are making 2 components for this maze. So we're going to be making the cover first, and then we're going to be making the body. And there's a very important reason why we're doing that. So let's get into the video and start talking about the thought process and methodologies that you want to follow when you're setting up a project on your CNC router. Let's go. idcwoodcraft.com. What I want to do first is cover what we're going to be doing here, talk about the router bits we're going to be using, how we're going to be setting things up, and then we're going to start carving this thing out. So I just want to make sure that you understand all this. Part of setting up the foundation here is for you to understand the toolpaths that we're going to be running to make this marble maze. So I'm going to explain that real quick, then we'll get back up to the CNC router and tell you what bits we're going to be using and how we're going to be setting things up, and then we get to go through the fun of actually running the project out. So there are 6 different toolpaths. There are 4 toolpaths to actually make the maze itself, this part, and then there are 2 toolpaths to make the cover. So let's get into my Vectric software, and I'm going to show you these toolpaths. So here we are, and you see in the screen to the left, there is the maze. And then to the right of the maze, there is the cover. So we're going to look at the cover toolpaths first. We are going to run the cover first, and I'll explain that in a little bit, why we're going to do that. Now you notice down here, for cover, there are 2 toolpaths. There's one called holes, and then there's one called cover cutout. And if you look at the design, you can see there are 4 holes there. The screws that are going to actually screw it to the maze body, that's what those holes are, and then of course the cutout. So we're going to select the cover holes. I have to switch over to 3D, and there is the main cover right there, and it looks like wood, but it's actually plexiglass. And we're going to run that. This is the holes. It's going to cut the 4 holes, and there they are. And we're going to do this with a 1/8 oval loop bit, and then we got the cover cutout. So I'm going to select that toolpath, run that one, and very simple, very basic. There is the toolpath to create the plexiglass clear cover that's going to go on top of the maze. Now let's take a look at the other 4 toolpaths for the maze. Now before I do that, you notice these are done in an order. The first one is cover holes, and then the color cutout. And the maze itself also has 4 toolpaths that we want to run in a certain order. So I've switched over to the maze by clicking this drop down, and that took us to sheet maze. Now if you want to learn about sheets, then you definitely want to go watch video 1 and 2, the design aspect and the toolpath aspect, so you understand what sheets are. It's a very useful tool, especially when you're making assemblies. So there are 4 toolpaths for the maze, and it goes in this order: the maze recess, then the maze track, then the holes, and then the cutout. So we are doing this in a process of the down and out rule. All right, well, we're removing the material downward to make the cover sit in there. Then we get to the maze itself. Then we drill the holes to hold the cover down, and then we do the cutout. We want to follow that certain procedure. The down and out rule is a video I made. It's something you want to watch so you understand how to think about the order of operations when you're making a project. So coming back into the Vectric software, I'm going to select the first one as the maze recess. That's where the cover is going to sit in. I'm going to click that, and that's what it's going to look like. The next one is the track for the marble. And there it is, very cool. You will have so much fun watching that and actually doing it yourself. The third one are the holes, a very quick tool path where we're going to use a drill bit on. Click that and you can see there is the hole right there. And finally, fourth is the cutout. And click that and there is the cutout, just like that. Okay, I want to redo this tool path because I do want to show you something that we are going to make a note on. So I rerun that. You notice over here there's this little lip right here. That's where we're using the lead in and lead out, which I discuss in video number 2. If you want to understand how to avoid getting some tool marks on your project, then definitely watch video 2. Again, those 2 videos are linked down below. I do recommend you watch all 3 of these videos. All right, let's get back out to the CNC router. Let's talk about the router bits and some of the other stuff to lead up to this whole setup. Now, the reason I'm doing this is because I want you to understand the foundations that we are actually running this Marble Maze out on your CNC router, so that you know how to do this kind of stuff from now on and not have any problems. First of all, like I said before, the first thing we're going to be cutting out is the cover for the Marble Maze, because we have to make sure that when we carve out this area, this cover is going to fit into the maze. If not, we can open up this area right there, so everything will work out good. And then we'll get to the maze, we'll carve out the pocket, we'll drill the holes, we'll do the maze itself, and then we'll cut the whole thing out. So let's talk about the CNC router bits that you're going to be using on this project. The first thing we're going to be cutting is the cover. So we're going to be using the 1/8 O-flute bit. This little guy right here. And you can see it's got a very interesting type of look to it. And what I said before, that spiral right there runs very quick, and what it does, it just pulls those plastic chips away from the cover really fast. And it's got just a different profile to it. So whenever you're cutting plastic, an O-flute bit is the bit you want to use. This is going to be the first one we're going to set up, and it's going to be the only one that we're going to use on the piece of plexiglass, this guy right here. After we're done with the O-flute bit, we're going to set this guy up. And we're going to go straight into the 3/16 compression end mill. And that's this guy right here. Now, I'm using the 3/16 instead of a 1/4 inch compression because of the upcut part of the compression. I want to make sure that that stays below the edge of the little cutout we do here. And like I said, I just haven't used it in a long time. So that's the bit we're going to be using. Once we create this pocket here, we're going to switch over to the lightning bit from IDC Woodcraft, the 1/8 carbide drill bit. Now this guy right here, and as you can see in this little video right here, this bit runs very, very quick. So this is going to be a very fast run for just 4 holes, but these holes are going to be placed accurately. You definitely want to use your CNC to place these holes because you want the holes in here to match up with the holes in here. Once we do that, we get into the coolest part of this whole project, and that is carve out the maze itself. Now, the maze, I said we were going to use a 1/4 inch ball nose end mill, but we're not going to use your traditional 1/4 inch ball nose end mill. This is the traditional one. As we turn it in the spindle just like that, you see the flutes go upward, and that's going to kick the chips out, but it's also going to cause a serious tear out. So what I mean by tear out is you see this cut right here. This is cut with a 1/4 inch ball nose, and you can see how much it has torn up the wood. What do you think it's going to do to your maze over here? So instead of using an upcut, we're going to use a brand new design that I've come up with, and that is a 1/4 inch downcut ball nose end mill. This has just been released from IDC Woodcraft, and you can see as we turn it, the flutes are going downwards, so that's going to eliminate tear out, and you can see the difference dramatically on this piece of material right here. This is done with the downcut ball nose. This is done with the upcut ball nose. Same depth of cut, same feeds, same speeds. The difference between the two is night and day. If you don't use the downcut ball nose on this, you're going to have all kinds of this tear out in your maze, and it's going to basically effectively detract from the look of the maze and leave you with a whole lot of sanding. So once we get that cool part done, and that's the most fun part to watch in this whole project, once we get that done, we are going to go back to our 3/16 compression end mill, this guy right there, and we're going to do the profile cutout, and it's going to make 3 passes around and cut that out. So with that, those are the CNC router bits we're going to be using. One of the things I do want to tell you, if you don't have a spindle on your machine, a spindle has an ER collet, and this is a 1/8 collet. So we are going to be using 1/1/8 shank bit, which is the O-flute bit. It fits right in there, just like that. If your machine does not have a 1/8 collet, if you have like a Makita router, you can get a 1/8 collet from IDC Woodcraft, or you can get a collet adapter. I do recommend this adapter here. This is for a 1/4 inch collet, and it has a 1/8 hole in it. And this is a super high precision collet. So if you don't have that, you might want to get that anyway. With that, we are going to cut down the plexiglass piece to the size that I want, and then we're going to set it up on the machine. The piece of plexiglass that we're going to be using now is held down, and I want to talk to you a little bit about how I've got it held down here. You see I've got these little clamps here, and they're just holding the edge of the plexiglass here. One of the things you always want to be aware of is the height of bolts like this. I know that we're okay, so I'm not going to worry about it. We're going to set our 0 point at the surface here on the bed, machine bed, for everything we're doing, and at the upper left corner right there. And the reason I do that, I set this in the upper left corner. Traditionally, people like to set it in the lower left corner. The reason I do that is because when the machine is done, it will stop and come back over here. So it will literally be out of the way when the machine stops. When you set it up on the front left corner, which is here, what ends up happening is then you've got to move the machine back before you can do anything else. So that's that. I do want to talk to you a little bit about the machine that I'm using. It's the Altmill CNC router made by CNC Labs. A super affordable machine that's built really, really well. And this is like my preferred machine now. I've been through 4 different CNC routers, and I like, this is the best one I've had so far. If you are considering upgrading your CNC router, or you are still in the market for a CNC router, then definitely check this out. I have a deep dive review video on the Altmill CNC. So we are going to put the 1/8 O-flute bit into the collet. So we're going to take this one out. It's a 1/4 inch collet. This is what we call an ER style collet. And we're just going to pop that out. And one of the things you do whenever you change a router bit is you remove all the sawdust out of the router bit. So you always want to, every time you change it, you always want to do that, because sawdust gets into the collet and it can act like little ball bearings. And what happens is, as the machine is running, the router bit just slips between those ball bearings, between the collet and the bit, and then you have something called bit slip, and that will happen gradually and progressively as the carve is going, and by the time you realize that your project is ruined because your router bit almost always slips downward. So it's super, super important to make sure that you always clean the sawdust out of your collet every time you change a bit. So we've changed over to the 1/8 ER collet, and by the way, cleaning out sawdust, you also want to clean up inside the spindle right up there. So let's get this guy in there. And I'll slip that bit up, and we're going to make sure we slip it up far enough so only that much is sticking out from my thumbnail right there. Sometimes I see people wanting to stick their router bits out a lot further just to get some extra length. And that's not a good practice to do without adjusting feeds and speeds. Sometimes I'll see people try to stick their router bit almost all the way out of the collet, just to get really deep. And you're asking yourself to break your bit. I've got a table that shows you exactly how to set your router bits up and what you have to do if you need to change it. You can see it right here. It's called the CNC Router Bit Chucking Guide. That's available to you for free. I'll put a link down below in the description, like everything else I am putting in the description, including the router bits that we are doing. So there we are, we're ready to go. So now I want to zero this out. First, I'm going to set the Z, and then I'm going to set my X and Y. And now we have set our Z. Now we're going to set the X and Y manually. I'm basically going to eyeball this bit right over the corner, right here, because I don't really need to be really accurate. This has got a lot of waste material on it, so I'm just going to eyeball the X and Y. I've got plenty of room. And the first thing we're going to do is drill the holes in this once I get it positioned. And I will repeat this for everything that I do here. Once I set the X and Y for one component that I have bolted down, I will never change that X and Y again until I'm done with that part, because my X and Y will never change. When we change a router bit, we have to reset our Z. So it looks like we are right where I want to be. I'm just going to move the Y a little bit more. My machine is talking to me a little bit. We're going to load the very first program that's going to drill the 4 holes. It's going to be super quick. Remember, it's using that spiral plunge toolpath. So with that toolpath, we can go any hole size we want and be very accurate with it. Now, when you start, you always take your tools off your machine. You want nothing in the way. I want to stop and explain to you what a spiral plunge toolpath is. It's a technique to actually create a circle any size that you want. So you need to drill a hole that is an unusual size, that is maybe 0.23764, something like that. You can actually create that circle in your software, and then using a profile toolpath, you can do what we call a spiral ramping type of toolpath. And what that is the router bit will actually come in and interpolate around that circle. So if you have a certain size, it'll interpolate, that's the word, around that circle, and it'll ramp down as it's doing that. And you can get very, very accurate hole sizes that are unusual sizes, so that you don't have to try to find some kind of special drill to actually drill those holes. It's a very handy toolpath to use and a technique to use. I go through that in the first video where we actually do the design work of this video. So in the plastic piece that we are going to be making first, for the little holes, which is maybe a little hard to see here, this is using that spiral ramping. We're using an O-flute bit instead of a drill to actually cut that hole. It's going to be very quick. They are always very quick, and the same tool will actually go around and cut out the part at the same time. All right, let's get back to this. Now that we have everything set up, we're going to load the G code for the holes. Remember, that's the first thing we're going to be doing for the cover. So I'm in the G-Sender control software. This is what actually runs my CNC router. G-Sender is a software that I recommend that you use for your CNC router because it's so user-friendly, it's very modern, it's constantly being worked on, it's got a ton of automation in the background. Many of the other controllers that are available to you, you have to do background work to it, meaning you have to change COM ports and things like that. So if you want it easy or you're not computer savvy, definitely get G-Sender. I'm going to link that down below in the description as well as everything else that I've been talking about. So in G-Sender, we are going to click the load file button and we are going to come to the directory, and this is the one we want to do, the holes, and you can tell right there, and you can see this is why we name the toolpath like this with the router bit, OF18. I know this is the O-flute 18, and as that number 1 indicates that's the first toolpath we're going to be running, the holes. So I'm going to double click that, and I'm going to put my hearing protection on. So the spindle is winding up right now. It's set to have a pause or a dwell in it, so the spindle can come up to speed before it actually starts to move. And that's how fast it is to drill holes with the spiral drilling toolpath. The next thing we're going to load up is the cutout of the cover, and that's going to be done. Now we get to load the new program, the cover cutout, and there it is, Maze cover, second toolpath number 2, cutout, OF18, same router bit, select that, click OK or open, and click the start job. This is going to make 2 passes around. You can tell by looking right there. You see the 2 lines right there? That means we're going to be making 2 passes. Here we go. RPM. The chips that we're getting out of this are nice. You can see they're kind of stuck in there. They should actually be popping out, so you might need to adjust the feed rate on the speed just a little bit. Now we're going to get into the fun part where we actually get to start carving out the maze, and it's so much fun to watch this maze. First of all, I want to remind you that this maze design file with instructions and the G-code is available to you when you get the specific bit that we are going to be using to carve out the maze itself. It's a new design from IDC Woodcraft that leaves a really nice top finish where you don't get tear out and chip out. And it just makes it look really, really good and saves you a ton of post work after the machining. Basically, it comes off done. And we are going to be cutting this out of what we call BamX. So BamX is bamboo, and it's a plywood. And it is a very nice, heavy piece of material. And basically, this is right off the machine, literally. So it looks done right off the machine. Don't have to do any finish work other than maybe sanding the edges here to get a little roundedness to break the sharp corners. So I'm going to talk to you a little bit about how we're going to approach this, and then we're going to get into it. First, if this video is helpful so far, then please give me a thumbs up down below and maybe even a comment. Ask a question in the comments and I can answer them in a video. If I answer your question from a comment, I will definitely give you a shout out. Also, subscribe to the channel. I just deep dive into all this kind of stuff just like this video. Remember, there are 3 videos to this marble maze. Video number 1 is how we go through the design work, the philosophy behind it, and the thinking. Video number 2 is the tool paths, how to set them up, the order of operations you want to follow, and then video 3, of course, is this video. So those videos will be linked down below in the description. All right, so here's how we're going to approach this. We are going to follow something called the down and out rule. That's, if you watch video number 2, you'll kind of see what I'm talking about. The down and out rule is a philosophy of setting up your order of operations when you're going to carve out your project on your CNC router or any machining. And the down and out rule basically says you remove all the material downward that you can, and then you work your way out. So basically you're roughing downward and then you're finishing out. I have a video that kind of dives into that quite a bit deeper to really help you understand the philosophy behind it and why you want to do it that way. In this case, we need to remove this material here so we can get to the maze and do the drill holes that are going to hold the cover down. So that's going down, and then we work our way out. So in this case, here's the order of operations. We are going to do this recess, fit the component, the cover, make sure it fits. And if it doesn't, then we will rerun it after we do a tweak to the program. And then we will drill the holes, then we'll do the maze, and then we'll do the cutout. Now, with the down and out rule, the holes are outside the maze. So you'd want to be starting from center outward. In this case, it doesn't really matter because the holes and the maze are just kind of in the same element of finished components, basically. And it is actually the out rule. So when you're following the out rule, you can pretty much do anything going outward In this case, I just chose to do the drill holes first and then cut the maze second. Now, cutting the maze is going to be a lot of fun. It's so much fun to watch this maze cut. And this is why you probably want to get this file, just to get that enjoyment. But at the end of the day, you end up with a very cool project like this that sits on your coffee table, and people will just play with it when it's sitting there and they come over and visit you. All right, with that, let's get into the setup of this project. Make sure you drop by idcwoodcraft.com for your CNC router bits as well. Got a complete line of bits to make your amazing CNC projects. All right, let's get into cutting out the maze. One of the things that we probably want to do is adjust the feeds and speeds on this just a little bit, because these chips should have been pulled out, but they're still nice chips. It's a little bit fine for an O-flute bit, but at least nothing stuck to the router bit itself. All the chips have broken away. Let's just peel this guy up and see how it turned out. How our cuts are. There we go. Oh yeah, take a close look at this cut right here. Let's get it into the light so you can see. Nice clean cut. The top edge is nice and clean as well. Excellent, exactly what we want. Well, my friend, we have finished the first component of the marble maze, the cover. So we have drilled the holes of the cover with that spiral toolpath that you can see right here. It happened so fast in this process that it's almost, you almost missed it. And then we did the cutout of the plastic. Now, with the plastic, of course, you always want to use the O-flute bits. They always do much better with the actual finish of the cut. The thing I want to talk to you about right now is, you notice we did the cover first, and then we did we're going to do the maze second. And there's a specific reason for that. And I want you to pay attention to this. You always want to do the male component first and then do the female component. And the reason you want to do that is when you have this ready to fit into the female component and you do the cut, in this case, the pocket recess here where this cover is going to fit in, you want to be able to do a test fit before you move on. And you want to make sure that it's going to fit in properly, like this cover is right here. If it doesn't, then you can run your toolpath again. You can do some slight modifications and then run the toolpath again. If you do it backwards and you do the female side first, the more fun part of the project, and then you do this and it doesn't fit, then you manually have to go and tweak this component. So you always do the male component first. That'll fit into the assembly of the female component. So here's how we're going to progress in this. We are going to, number one, carve the pocket, the recess for the cover, the one we just made. Number two, we're going to drill the 4 holes. And then 3, we're going to get to the really, really fun part, is carving out the maze. It's so much fun to watch. And finally, we're going to carve the whole thing out and have a completed project. Now, one of the things you're going to probably notice if you've done any design work, that I did not add tabs to this. Tabs are what attaches the finished piece to the waste material so it doesn't move around. And the reason for that is because we're using the 3/16 compression bit, and that is going to leave the chip load, most of it, inside the cutout. And that will actually brace the piece when it's being cut out so it doesn't move. It's one of those little cheats that you can do, a nice little pro tip for you when you're carving something, how you can get away without having tabs. So the router bit we're going to be using is the 3/16 compression end mill. This guy right there. And this has that little upcut area right there. And then it also has a down cut. So what the benefit to that is, it will eliminate tear out on the top of the material and also eliminate tear out on the bottom of the material. Now I'm going to give this finished project to you, not the project itself, but the file, instructions, the G-code, the design file, everything. So you can just run with it as it is to make it. So that's what we're doing there with the 3/16 compression bit. We're going to be doing this with the BamX material. So this BamX wood, as I've explained before, is a bamboo plywood. So it's entirely bamboo. It's just there's different colors here. And it's 3-ply, and it has a nice contrasting color tone. So when this thing comes off the machine, it is basically a finished project. The only thing you'll have to do is just do a little sanding around the edge to just round out or smooth out the sharp edges that are going to be on the top and the bottom. So the BamX comes as a 24-inch by 24-inch piece of wood, and it's very solid. And like I said before, the thickness of this is extremely consistent, and it always comes in flat. I know that this is 0.755 thick. Doesn't matter how many pieces I get, I can always count on that. So we're gonna set this up. The last thing, as we're doing this setup, remember what I said about the raster cut for the pocket. That we want to maintain our raster with the grain of this material right here, the second ply. So we're going to be running that way. And I made a note for myself, and you always want to make that note to set up your top grain the proper way. So the top grain is going to be going this way. So I know that the grain underneath is going that way. So my raster, I have designed it to go back and forth that way. As I set up this thing on the machine, one of the things that is important is the first thing we're going to be doing, like I said, is the pocket, this recess here. And we're going to do it in a raster cut. Now, raster cut is a cut that actually makes the router bit go back and forth. It's going to come across here, it's going to move up a little bit, come across and move up, go back, keep doing that, zigzagging up, as opposed to what we call an offset cut. Now, an offset cut actually starts in the middle and it works its way out in kind of a spiral format, kind of a square spiral. But we want to do this in a raster cut, and that video 2 explains why we want to do a raster cut. Basically, the router bit is going to be following the grain of the wood. And when it follows the grain, it doesn't leave tool marks. Now, in this project here, you won't see many tool marks just because there's so much material removed for the maze. But you want to get in the habit of doing a raster cut based on the grain direction. So here's a really key point here. This BamX is a ply. It's a 3-ply bamboo material. So as is traditional with plywood, the top piece will have a grain in one direction. Let's just do it from this way. The grain is going in this direction here. The second ply, the grain goes in that direction. So when we set this up on the CNC router, our raster cut is going to be going back and forth like that. And what that means is this actually needs to be facing like that, because the underside or the bottom of the recess, the grain is going the opposite direction. So we always want to just take that into account. I mentioned that in many videos that I have made for you, but it's a really important note if you want to avoid tool marks that you have to do a lot of sanding. You want to do raster cuts that follow along with the grain. All right, let's continue on getting this project set up and start carving it. Now, all that information is going to be in the instructions with this file. Also, I'm going to show you a special router bit in this that if you get the router bit, it will work out really well for you. But I'll talk about that in a little while. And if you get the router bit, I'm also going to give you the ball bearing for this and the file for this project. All right, with that, I am going to clamp this down, square it up. We're going to change out the bit. We're going to follow the same protocols. When we change the bit, we're going to clean out the collet. Then we're going to install the 3/16. Remember, we're set on the material machine bed. So my mark is right there. So what I'm going to do is I'm simply going to put it over, well, we'll just go like that. And I'll set my 0 right here, and the machine will be right over, or the material will be right over here. Just want to make sure the surface is very clean with this one, and then we'll clamp it down, 0 it out in the back left corner, and then we'll go to town. All right, we are ready to set our 0 point and change our router bit. So that's what I'm going to do. I'm going to change the bit. I'm going to clean the collet. I'm going to 0 the Z on the surface and this back left corner here. And then we're going to load up the file. the first one and we're going to carve it out. Just one more thing that I want you to always pay attention to, and this will be in the instructions as well, is your clamp position. So since I'm going off the back corner, I need to leave the clamp off the corner, so I've moved it over to here. But the other thing is always knowing exactly where your clamp is relative to the motion of your CNC router. For example, if this router was going to wrap it down to here and would cut across the clamp, it would break the router bit as it rapided. So there is a setup in the Vectric software. It's called a keep out zone setup, which I've created a video that explains how you can tell the software where the clamps are going to be at, and it'll generate the toolpath around the clamp. I know that this is not going to run into the clamp because I've already looked at the toolpath to make sure that that's not going to happen. So this is just a big heads up to be aware of. All right, we are just about ready to go. We're going to load this file up and we're going to cut out this pocket. This is where it gets really, really fun. And you're really going to enjoy it. So we're in the G-Center software. I'm going to load the file. The project is already zeroed out. We're going to go to the maze body, toolpath number 1, and this is the recess, and it's the CM316, so the compression 3/16 end mill. We're going to load that up. We have to click that and then say open, and there it is. It's ready to rock and roll. I'm putting my hand on the emergency stop button. I'm double checking my 0 locations. Everything is looking good. We're going to hit start. Let's do it. Now when I was talking about the raster cut, we are doing that right here. You can see the router bit is going back and forth. It goes one direction, moves up a little bit, comes back across. And what it's doing, it's following the grain of the second ply so we don't get any tool marks. But it is going across the grain or at a right angle to the grain of the top ply. So this is okay because we're removing all the material. Now, because we're using a compression end mill and we're cutting deep enough, the down cut part of the compression end mill is actually doing a down cut on the top edge, so it's leaving a very clean top edge as opposed to getting chip out and tear out. So we're actually getting two benefits at the same time by using the compression end mill in this particular cut. All right, we've got this one done. And this bit puts out some really nice chips. Now, one of the things with this bit is, or any compression bit, or many router bits, they are going to make noise, so you definitely have to have hearing protection. The next part is to drill the 4 holes. Now, this is going to be a super fast drill cycle. It's just the way it is. By the way, if you were going to get this file, one of the things that I'm going to make available is the router bit bundle to make this file. So we're just going to call it the Maze bundle, where it has all the router bits that you need to actually create this whole project. I'll remind you about that again. Remember, down below in the description, there's all kinds of links and the information to get this file, but I'll remind you about that in a little while. I'm going to check to make sure that this plastic piece fits, but I got to clean things up a little bit to clear out my pocket here. This is exactly what we need to do, and this is exactly why we want to cut this piece first. And it fits that way. I'm not dropping all the way because I won't be able to get it back out. Fits that way. Now, one of the things I want to say is if you attempt to drop it in and it doesn't fit, what I'm going to say is simply just rerun the entire toolpath, because what has probably happened is you got a little bit of router bit deflection, and what that would do is the router bit would just flex in just a little bit and maybe just a hair undersized. And so if you run it again, that deflection won't be there because there won't be any pressure, and it'll just trim that excess off and then try it. If that doesn't work, then go back into the program and you'll just upsize that the recess here just a little bit. I mean, just a little bit, like a 0.005, and then rerun it. Let's talk a little bit about what router bit deflection is, especially if you're brand new. This is something you need to be aware of. When a router bit is actually making its passes through a project, even though a router bit is made of carbide, which is very stiff, it still does do a little bit of bending. When it's doing the work to cut out the wood, there's resistance from the wood. And the rotation of the router bit itself actually causes things to deflect. So the router bit itself can actually flex just a little bit. It's just like this piece of wood. I can't really bend it too easily. The same with the router bit. It doesn't bend very easily, but it does get a little deflection. And there is compound effect of router bit deflection. You have a router bit on your CNC router, and then there's all the mounting components for the machine itself, and those can have a very slight amount of play as well. So what will happen as it's doing that work, that rotation of the bit actually wants to push away from the cut. And so that causes a little bit of deflection as well. There's pressure working against the bit. And so there's forces that are being applied. So that's what router bit deflection is. And when you're doing a mating component like this, you really have to be aware that deflection is an issue, especially if you're doing very tight fits, like we're doing here. I mean, in the design work in video 1, we did compensate for the size of this relative to this to make sure it fits in here. We made this just a little bit smaller than the recessed cutout here. But deflection is a big deal. So if your cover does not fit in the first time, I just want to repeat this, just run that cycle again and it will clean up just a little bit of stuff because there was deflection as it was running. And then try to fit it again. And if it doesn't fit, then go back to your design. Like I said before, upsize it just a little bit, 0.005, and then regenerate the tool path and run it again. All right, so now we're getting ready to go to the drill holes. These guys right here, we're going to drill these 4 holes. And we're going to do that with the IDC Woodcraft 1/8 carbide lightning drill. It's designed specifically for CNC routers. I had the point of this ground very specifically with 2 different bevels on it so it will kick the chips out of the drill hole really fast. And the benefit to this type of drill bit, the way I've had it designed, is it can handle the high speed of CNC routers, whereas most drills can't. A lot of people will drill their holes with end mills and they have to do peck drilling. Or even with drill bits, you have to peck drill. This is designed to kick the chips out right away. You can plunge drill without pecking up to 1 inch. And this is a superb bit for those who like to make cribbage boards because there are so many holes in cribbage boards. So what I'm going to do now is I am going to set up the router bit and get it zeroed out, and then we're going to come back. Now this time, what I'm not going to do is swap out the ER collet from a 1/4 inch shank collet that's in there to the 1/8 shank. Instead, I'm just going to use this ultra precision collet that you can use for your collets if you don't have a 1/8 reducing collet. This is a very precision collet. It runs true to within 1/1000th of an inch. Just simply slip it in, and we are going to go to the top of the flute cut, which is right there. We're basically going to have it just like that. This guy is going to slip up right inside there, just like that. And we're going to tighten everything down and zero it out. Load up our program and rock and roll. So you can see how that collet sits in there. Now, when you're tightening router bits, you don't want to super hard tighten them because you'll wear out your collets that way. You got to snug it down, you'll feel it grab, and then you give it a little bit more turn. Now, when you're using a collet adapter like we just had, you do want to give it an extra snug. So if we're set up, ready to go, other than my zeroing out and loading the program, we'll take care of that, and then we're going to start this. All right, so now we are ready to drill the holes. I've zeroed everything out. Now we're going to load the file. So one of the things that I did when I was doing this, remember I told you, when you want to do a design, you work down and out. So that means file number 2 should be the maze. And we're doing the drill holes, which are outside the maze. So when I have created this file, that's the way I designed it here. But I got a little confused, but I know that we're okay. We're just drilling holes, and then we're gonna come back and do the maze. So we're gonna let that one slide. So we're gonna find that. It's maze body, and it's file number 3, the hole. And we're using the DR18, the 1/8 drill. Gonna click OK after we select the file. There it is. This is gonna run really, really fast. Now, I wanna show you something about the Altmill CNC router, which again, I'm going to suggest that you take a look at that. This is a 4x4 machine. CNC Labs, the one that makes the machine, they're going to be coming out with a 4-foot wide by 2-foot deep machine very shortly. You can check out the description. There will be a link for that information, like I said, down below. But I want you to notice where the drill is at right now. If I tell it to move, generally, we're going to think it's going to go straight over to the XY0 when I tell it to go there. And what it'll do, it'll hit this clamp. But this is set up in such a way that it won't hit the clamp. If I tell it to go to XY0, it's gonna come way up and then move over. So we're gonna do that right now. It's a safety thing that I know that I can get away with. Normally I wouldn't even do this myself. I wouldn't even trust it. But we're gonna let it rock and roll. I just wanna show you, this is how the Altmill is set up. So here we go. Get your camera on there. I'm going to click the button, go to XY0. It's going to pull way up. That moves so fast. This is what I really like about this machine. All right, we're going to run this out. It's going to go out really quick. Get my hearing aid on, or hearing protection. Hit the start button. Router bit, it drills at 50 inches per minute. You're going to see it's going to plunge a 1/2 inch in. And watch how fast this lightning bit drills. And think about making a cribbage board. That's it. It's almost not even worth the time to actually use that drill bit. But we need to make sure our holes are in the right place. So we're done with that. I'm going to first just load up the next program, which is the maze. So that is going to be maze body, maze track. We're going to use this bit called BD14. So let's get that loaded up. So this is a very different router bit from IDC Woodcraft. Remember, we're using a ball nose end mill to carve out the maze. Where do I have my maze at? It's right over here. And the reason I use a ball nose to carve out a maze is it just makes a nice track for the marble to run around in. I don't like using flat router bits to do that. Now, generally, you'd be using the 1/4 inch ball nose, which is an upcut end mill. Almost all ball nose end mills are upcut. But I got tired of all the tear out that happens with ball nose. It's just, it's not necessary. So I don't know why someone didn't come up with it, but I did. I came up with the design with a downcut 1/4 inch ball nose, and you're going to be amazed at how clean this thing actually cuts. Now, if you look at this piece of pine right here, these are 3 cuts that were made with the 1/4 inch upcut ball nose, the standard ball nose that you get. Look how messed up that is. It's just really sloppy. You have to sand all that out. Over here is using the downcut. Now, I've turned the speed way up to like 400 inches per minute, and the spindle couldn't handle it, so it stalled, and then moved the thing and broke the router bit. But let's take a look at the back of this, where I was actually running it on this BamX. And you can see clearly what an upcut ball nose does versus a downcut ball nose. This is a router bit, this downcut ball nose. If you decide to get that bit, we're going to send the ball bearing with it, the 3/16 ball bearing for this maze, and you're going to get the maze file with that ball nose as well. All right, so I am going to switch out to the 1/4 inch downcut ball nose. This is the most fun part of this entire process, where we actually get to carve out the maze. It's so much fun to watch the maze carve. We're gonna get the bit changed over and hit it. This is my favorite part. We got everything set up. I do want to talk a little bit about this downcut ball nose. Also, you'll notice it's gold color. That's zirconium carbonitride coating. It's the hardest coating that you can get on a CNC router bit. What that does is it has this lubricity property, which means it allows the wood chips to slide out a lot faster. It has a heat tolerance to it of 1500 degrees Fahrenheit. And what that means, it just resists heat before it starts to break down. It also creates a shield, a heat shield between the router bit and the material. Heat with router bits is the biggest enemy. So you always want that heat to be pushed away from the router bit itself. So you want it to go into the chips or anywhere else, but you don't want it in the router bit. Well, you don't want it in your project either. I've seen that happen. All right, we are going to go fire this puppy up. My favorite part of this whole thing. Here we go. Yes. Well, that was a lot of fun. This is done. Now all we have to do is simply do the cutout. We're gonna go back to the 3/16 compression end mill. I've shown you how to load the program, so I'm not going to go back into the G-Center to show you how to do that. I'm just gonna change a bit. You get to watch it cut out, and then we'll come back. Now, I said earlier in the video that this file with the G code, the design file, SVG and DXF files, and instructions are available to you for free when you get a specific router bit from IDC Woodcraft. That router bit is the 1/4 inch downcut ball nose end mill. That's this guy right here. And you can see how clean these top edges are on the project. This is all directly off the machine. When you use either straight ball nose end mills or upcut ball nose end mills, you're going to get all kinds of chip out going on. And with a project like this, with so much work on it, imagine all the sanding you'd have to do, and even the chip out that you would get in corners like this that would take away from the project itself. So if you want to get this file, the instructions, the design file, and the G code, that comes free with the 1/4 inch downcut ball nose end mill from IDC Woodcraft. And we also send you automatically a steel ball bearing. Basically, anybody who buys this bit gets this file for free and gets the ball bearing. And of course, if you want to get all 4 bits that are needed to make this entire project, we sell that as a bundle as well, and you will still get the file and the ball bearing. So all 4 bits are the 1/4 inch downcut ball nose end mill that makes really clean cuts, just like what's on your Marble Maze here. The 1/8 O flute, the 1/8 lightning drill bit to drill the holes, and the 3/16 compression end mill to do the cutout and to do the recess. All right, now it's time to do the cutout. If you remember, when we're doing this cutout, I showed you how to put a lead in and a lead out, so you don't have that little mark along the edge of the material or the piece when you get it cut out. So that lead in and lead out is going to happen right in this corner. Now, I know I'm clear on this clamp, but I'm just going to move it back just a little bit. Just a little bit, just like that. Watch the lead in, right there. So we didn't use tabs on this. And if you look in here, you can see it here. All the chips are here. They're all compressed in here. So just the compression of those bits will keep the part from moving. And now all we have to do is pull it out like that. Knock it over. And I want to take a look right over here. The router bit came down right here and it led in, so it just gradually fed into the project. And then when it came back over here, it led back out, and that eliminated the witness marks. So we got a bit of stuff on here on the sides. We're gonna just get that cleaned up. Let's get a ball bearing and drop it in. Oh, look at that. Marble runs around there quite nicely. Now we're just gonna put the top on. Let's make sure it fits. Don't wanna lose my ball bearings. Gotta do a little cleanup on this whole thing, then we'll put it together. But basically, we definitely wanna keep the ball bearing in there before I put that on. Basically at this point, now all you have to do is take this guy, take your screws, put the ball bearing in, make sure you've cleaned out all the little hairs that might be in here. Like for example, I see a couple little hairs that are hanging off the wood in here. So just do a quick look in here. You probably can't catch it on the camera. And then we'll take our screws and we'll use them and just screw things down. And the whole project will be done. If you want to, you take a little sandpaper, clean it up, or you can use, what I like to use is my 1/8 roundover on my trim router, my handheld router, as opposed to doing it on the CNC because it's just a lot faster that way. Let's put this thing together. Now we have everything cut out. At this point, all you have to do is do the assembly and you will have a finished project. You might want to just sand off the edges a little bit just to kind of take off the sharp corner that's going to be there. Remember, this file is available to you for free when you get the 1/4 inch downcut ball nose end mill from IDC Woodcraft. The ball nose bit will leave very clean cuts for you, and this is a really fun project. And when you get that bit, you will get the 3/16 ball bearing for your Marble Maze, and you can get all the bits as a kit as well. If you got something out of this video, please take a minute and hit the thumbs up button. You got questions, put them down in the comments, because sometimes I shoot videos if they're good questions. And if it's your question, you'll get a shout out in the video as well. And if you have any suggestions on how I could have done this better, I would love to hear it. And make sure you subscribe to the channel and drop by idcwoodcraft.com for your CNC router bits so you can get your amazing CNC projects carved out amazingly well. With that, my CNC friend, I hope you got something out of this. Just remember, below in the description of the video are lots of links, and there's video 1 where we talk about how to design this up, video 2, set up the toolpaths, and of course, this video, running this project out with this end result. This is really cool because it is one of those things you can make and leave on your coffee table, and anytime someone comes over, they just start to play with it. It's just a natural hand grab thing. I don't know why, but people just like to mess with it. And it's just a heck of a lot of fun to make, especially watching that maze carve out. With that, you have yourself a great CNC day, and I'll see you in the next video. idcwoodcraft.com